All right, for the 6.6 study guide, we're now going to be talking about all these transformations of several different kinds of graphs, not just a parabola anymore. So let's take a quick peek at this first term, transformations. It's a change of the figure or function. Usually a shift, a compression, or a reflection of the original. Now, the three transformations that we studied in Math 1 were translation, moving a shaped right, left, up, or down, rotation, 90, 180 degrees, and reflection, or flipping the image. So these are the three transformations we're supposed to be solid on from Math 1. And then we're going to learn a new transformation called dilation later in this semester. So when you transform a parent function, you change its location or you change its shape. So we're going to be looking at different parent functions here in a second. Let's write compress, flip, shift, or stretch in each of these blanks. So when you move the graph up, down, left, or right, this is called shift. And the real word for this is translation. When you pull the graph away from the x-axis, this one, what do you guys think? Is stretch. When you push the graph towards the x-axis, it's compress. And when you reflect the graph over a line, it's flip, known as reflection. Okay, so for a rule like this, f of x plus k, this would be a shift up k units. And this is when we add a positive number to the entire function. We did this a couple days ago. When it's f of x minus k, this is a shift down of the function, and it's when you subtract a value from the entire function. When it's f of x plus k, this is a shift left. Remember that a plus is a left shift inside the parentheses. This is when you add a number to every input. For a shift right, it's when you've got f of x minus k, and it's when you subtract a number from every input variable. A vertical stretch is when we multiply the entire function. It's what we just did in our last unit. So where it's some number k times the function, where k is greater than 1, that's the vertical stretch. And a vertical compression is when we multiply the entire function by a fraction. Flipping over the x-axis is when you multiply the entire function by -1, negative f of x. Flipping over the y-axis is when you multiply the entire input or variable by -1. A horizontal stretch is when you multiply the variable by a fraction, and a horizontal compression is when you multiply the input by a number that is greater than 1 or less than -1. So this is all the rules together of everything we've done over the last several lessons, all in one table to look at. So that's kind of nice. All right, let's finish this off. Look at number 3. Write the equation for the parent function and then tell how it was transformed. Each graph below shows a parent function that was transformed in one way. So picture this linear equation. It's just a plain line. The parent function is just y equals -x. Oh, sorry. The parent function is y equals x. And the change is that instead of it going in the positive x line, it's now a negative sloping line. So the change is a flip over the x-axis. Because it's now got a negative slope. And so the correct function is that g of x is equal to -x. So the original function was just x, and the new function is -x. This is the parent function of y equal to the absolute value of x. It's a V-shaped graph. We did this way back in Unit 1, way back in Unit 1 of Apex, looking at absolute value graphs. This one has been shifted right 1, 2, 3. So the change is a shift right 3. And so what does my function look like? Everywhere that there's an x, it's now going to be an x minus 3 for the shift right. So notice this x changed to an x minus 3 because it shifted right 3. There's the new vertex. Here was the original parent graph. All right, let's go look at the checkup questions. This is kind of a short one, so we're going to just do one video. All right, let's talk about the shift from the parent function. Is it up or down? So if you shift the linear parent function up 6 units, what's the equation of the new function? So the new function g of x is the original function, x, shifted up 6. So just plus 6, done. If you shift this quadratic parent function down 10 units, what's the new equation? So new function g of x, take the original, shift it down 10. Done. If you shift this absolute value graph left 4 units, you're going to take the original function. Everywhere that there's an x, you're going to turn it into a left shift and change it to x plus 4. Here's your function, g of x equals x plus 4. Now they're giving us an exponential function. They're saying, what about doing a right 2 units? So we're going to go take the original function, 2 to the power of x. Everywhere that there was an x is now going to become right shift of 2, so it's to the power of x minus 2. Done. For 5 and 6, we're now going to do vertical and horizontal stretches. So if you vertically stretch a linear function by a factor of 8, what would the new function be? So g of x is now 8 times the original. Vertical stretch is a nice 8 right in front. If you horizontally stretch this quadratic parent function by a factor of 4, what's the new one? Remember that horizontally means you're going to be changing the input inside the parentheses. So g of x equals, what fraction is going to go here when it's a horizontal stretch? If it's a factor of 4, it's turning into 1/4 x squared. Remember to look back at the table if you're not getting these right, if they're not sticking in your brain yet. No problem to look at the notes. All right, last 4, let's take a check on these. Number 7 says, if you flip an absolute value parent function, so picture a V-shaped graph, we want it to completely flip upside down, but stay with the same origin. So this is going to be g of x is equal to, just throw a negative out front and it flips it. Done. If you flip this linear parent across the y-axis, what is the equation of the new function? Again, just flipping that. It goes from regular x to negative x. Done. Finally, 9 and 10, if you apply the changes below to the absolute value parent function, what is the equation of the new function? So we want to vertically compress by a factor of 2, and we want to flip it over the x-axis. That means a negative is going to be in there. So here I go. New function g of x is equal to vertically compressing factor of 2. That's going to be negative 1/2. Well, technically it's just the 1/2. And then the negative is because of the flip. And then don't forget the absolute value of x. Why is there no change inside with the x? Because this is a vertical compression, not a horizontal. Remember, horizontal changes inside and vertical changes outside. Finally, number 10, shifting 7 units right and 3 units up. Original function is x squared. So here I go, g of x equals, something's going to happen to the inside with the x and something happens at the end. Shifting 3 units up, shifting 7 units right, and we're done. How'd you do writing these functions?